Welcome. Let's look at graphing equations if they're already in slope-intercept form. So I have a couple of examples here and then a couple of exceptions to look at, or rather variations. Right, first, the basics. Let's take a look at how we would figure this out. You have the 6 and you have the 5. That is the y-intercept. So that is where it hits the y-axis. Go and put a point on it. That's the first thing, even though it's second in the equation, it's the first thing to start with graphing. And then next, we have the slope, which in fraction form is 5/1 because that's the rise over the run. So starting with that y-intercept, we're now going to go up 5. We have to go over it. Okay. That's where the point would be. And because it's going off, what we should do is make them both negative. Negative 5 over negative 1 is the same as 5/1 because the negatives would cancel. But the negative 5 means we can go down, and the negative 1 means we can go to the left instead of the right. So now I can go down 5 and over 1, and then down 5 again. 2, 4, 5, over 1. Okay, so it's down 3, 4, 5, and over 1. And that means now I can get a line that goes through the y-intercept and all the other points that we could find by using the slope. Remember when graphing that you always have your line go all the way through to the ends of the graph, and if it's supposed to continue on, you have to put arrows on it. So 1 was to use the y-intercept, 2 was to use the slope. And we have now graphed the line. Let's now take a look at the second one. So for this one, the y-intercept is -8, and the slope is -4/5. What you can do is -4/5 or as 4 over -5, not for the purposes of writing, but rather for the purposes of the rise or going up or going down, the rise or the, I don't know what I call it, drop maybe, over the run, which is either that way or it's that way. Well, actually, let's do it's that way if it's positive, and it's that way if it's negative. Okay, so we go to the -8, 3, 4, 5, 6, 7, 8, and I have an up 4, 1, 2, 3, 4, and over 5, 1, 2, 3, 4, 5. Oh, wait a minute, one was supposed to be negative. So this one, if I was -4, I'd be going down here and then over. It'll be easier then to use this one, where we'll go up 4, 2, 3, 4, and then -5, 2, 3, 4, 5. And I'll go up 4 again, and then over 5, 2, 3, 4, 5. Ooh, all the way to here. So those are enough now for me to make a line through them. And that now, that's the line for this equation. That's it. In fact, I'll say, okay, there's my answer for that one. Here's my answer for this one. And we've got those first two. Now let's take a look at these. And we have to think about what they mean. These are too easy. People get confused about them because they're too busy trying to do the hard things with it. So what we're going to do is revert back to an XY table. If I say the X is 0, well, if the X is 0, that means the Y is 0. If I say the X is 1, the Y is 1. If I say the X is 2, then the Y is, oops, I put a 2. 1 and at 1. If I put the X is 2, Y is 2. And if the X is 3, Y is 3. So I'll plot those. 0, 0, 1, 1, 2, 2, 3, 3. Now, if I did negatives, let's say -4. If X is -4, well, then Y is the same thing. They're equal. So that means that this has to be -4 also. That did not end up coming out right there. So if X is -4, that makes Y -4 also. 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. Make more of a normal dot there. 1, 2, 3, 4, 3, 4. And then we'll put the line through it. Now, this one is a special line because it's the parent function for all linear equations. This is a little aside that y equals x. So think about the fact that the coefficient in front of the x is a 1. That means the slope is 1, which you can see if you look at the graph, we go up 1 and over 1, up 1 and over 1, and that y-intercept is 0. And that's y equals mx plus b form. Okay, that's an interesting way to think about that. This one, though, is different. Y is equal to 4. Now, people sometimes make a mistake with this, is what they'll do is they'll just use that one number, -4, and they'll go to where -4 is, and then they stop. But the fact is, y is -4 over here also. And y is -4 here. And y is -4 here. And here. And here. And here. And here. And here. And here. In fact, what about here? And here. And here. And here. And here. And here. And here. And in between them, y is -4 in all these spots. Y is -4 everywhere on that line. It doesn't matter what the x is. There's no x in that equation because it doesn't matter. Every single x is used with that -4, and that makes this kind of a line. So here, a problem people develop is they're so used to the y-axis going up and down that they think of the y-axis as going as, the line needs to be parallel to that. No, it doesn't. You analyze this, and let me actually analyze it also here. So the first one I put was something like at about 3. If the x is 3, y is -4. Let's pick 5 for the x. Well, this tells you the y is still -4. If x is -2, y is -4. If x is -10, y is -4. And that's where some of these points can come from. The y is always -4. So plot a few points like that, and you see, oh, you got it. Well, now let's look at this one. I'll put that one in green here. Or no, let's use black because that's actually easier to see on many of these. So for that one, let's do the same x, y. So x is equal to 7. I can't make the x equal to, say, 0 or 2 or 3 because the only thing here is that it can only be 7. So x is 7, and then the y is 0, or x is 7, y is -3, x is 7, y is 5. How did I get 0, -3, 5? I just picked them because it doesn't matter what y you put. Whatever y you put, the x that goes with it is 7. So it's 7 and 0, 7 and 84, 7 and -500 billion, 7 and 12. So that means, let's plot these because I chose those to make it a little easier. Let's go to where 7 is. 1, 2, 3, 4, 5, 6, 7. 7 on the y-axis because this line is actually the y equals 0 line. This one is the x equals 0, even though we call it the y-axis. This is the x-axis. But then for 7 and -3, this line here, this is x equals 0, this one's x equals 1, x equals 2, x equals 3. This one's the x equals 7 line. And so 7 and -3, 7 and 5, 3, 4, 5, all of these, all the points along here. So we get a vertical line for it. And in blue, I'm going to write, this one is y equals x. And then the red one is y equals -4. So you have vertical, horizontal, vertical, and the other one's sort of like the normal ones. I'll put this in y equals 1x plus 0. Let's make it blue. So on this one, this is just a normal type line, I guess you could say. With these variations, make sure you pay close attention to the horizontal and vertical lines and this y equals x. Make sure you know and understand the three of those. Whatever number is put here and here, make sure you're clear and understand those. Okay. The number can be different for the y and the x. On the other one, they always are equal. Okay, I hope that helps with looking at the graphs of these. This is part 1 of the 4.1 section. Thank you for watching and listening.